Hello, in this problem we're going to do a proof. We have that x is an element in the set of integers, and we're going to prove that 11x minus 7 is even if and only if x is odd. So before we do the proof, let me refresh your memory on what it means for an integer to be even and odd, because it's really important. So recall that we say that x is even. This is equivalent to saying that x is a multiple of 2. So x is equal to 2k for some integer k. So I'll say for some k, which is an element in the set of integers. You can also say for some integer k. You can write it out, but being lazy. And then x is odd. You can say that x is equal to 2k plus 1 for some k in z. So that's what it means for an integer to be even and an integer to be odd. So let's go ahead and do this proof. So we have two directions to prove. We have to prove that if this is true, then this is true, and if this is true, then this is true. That's what an if and only if means. It means that whenever this statement is true, this statement is true. Conversely, if this statement is true, then this statement is true. Let's start by proving if x is odd, then 11x minus 7 is even. So I'm going to put a little arrow here to indicate the direction we're proving. So I'm going to start by assuming this. So you write, suppose x is odd. And now you have to show that 11x minus 7 is even. So typically what you do now is you write down what it means for x to be odd. And if you really want to be clear, you can actually say, this means. So what does this mean? This means that x equals 2k plus 1 for some k and z. So x equals 2k plus 1 for some k and z. Okay? And then so now you have to show 11x minus 7 is even. So the natural thing to do is just write down 11x minus 7. So then 11x minus 7, well, you can plug in your x. So it's going to be 11 times 2k plus 1 minus 7. And that's going to be, let's see, 11 times 2k is 22k. 11 times 1 is 11. And then minus 7. So that's going to be 22k. 11 minus 7 is going to be 4. We're trying to show it's even, so we're trying to factor out a 2. We can do that, and we get 11k plus 2. So that's the definition of even, right? 2k. So this whole thing is going to be our k. So we should specify that it's an integer, where 11k plus 2 is in the set of integers. If you're curious as to why, you have a product of integers, so it's an integer. You have an integer plus an integer, so it's an integer. So this whole thing is an integer. So we have 11x minus 7 is equal to 2 times an integer. Hence, 11x minus 7 is even. So that completes that direction. Okay, now let's prove the other direction. So for this other direction, we have to prove that if 11x minus 7 is even, then x is odd. So instead of doing that, we're going to prove the contrapositive. We're going to prove that if x is even, then this is odd. So again, to prove that if this is true, then this is true, we're going to prove what's called the contrapositive, which basically means you prove that if this is not true, then this is not true. So what does it mean for this not to be true? It means that x is even. So we start by saying, suppose x is even. And now we have to show that 11x minus 7 is even is false. So to show it's odd, okay? So we're going to show that that expression is odd. So as before, write down what it means for this to be even. So this means x equals 2k for some k and z. And then, as before, we look at 11x minus 7, and we have to show it's odd, right? Because that's the opposite of even. We're doing the contrapositive. So we just plug it in. So this will be 11 times 2k minus 7. It's going to be, I'm going to come over here. It's going to be 22k minus 7. So we need to have a plus 1 here. So how can we do that? Let's see. Maybe we can write it like this. This is 22k minus 8 plus 1, right? Because that way it's the same thing as minus 7. And now I can pull out a 2 here. This will be 11k minus 4 plus 1, where 11k minus 4 is an element in the set of integers. It's a minus there, okay? Let me just clean that up so you can see it a little bit better. I have an eraser, I should use it. 11k minus 4 is in the set of integers. This shows 11k minus 7 is even. And that completes the proof. We've shown both directions. Again, just a really quick recap of the whole proof for you. So we had to show that 11x minus 7 is even if and only if x is odd. So first we assumed that if x was odd, and we showed 11x minus 7 was even. So that's this part of the proof here. Okay. And then the other direction was to show that if this is even, then this is odd. So instead we did the contrapositive. We showed that if this is false, then this is false. So we assumed x was even, we showed this was odd. So that should say odd there. That's a typo. See? Caught it by fixing it. So I meant to say odd, right? Not even. So easy little mistake, but it was fixed nonetheless. I hope this has been helpful to someone. Good luck.